Okay, in our previous videos lecture we have seen the mm, various base quantities, and from that we already learned that two quantities we should assume and other two quantities will be derived, and we will take two quantities, that is KVA base we have to select and KV base we have to select, and from that we should derive other two quantities. What are that? That two are mm, current base, current I base equals to KVA base divided by KV base, and from this impedance base, so Z base can be derived. Z base equals to Z base is equal to voltage KV base by current I base. We know Z is equal to V by I, and it is in kV, so convert it in V, so multiply it with 1000, so Z base equals to kV base into 1000 by I base. Now I base, it is like that, so replace I base through this. What will be? We have to replace I base through this KVA base, KVA base by KVA base by KV base, KV base. That means if we further proceed, then it will, this KV will be come here, so it will be KV base square. This KV will come here, so it will be KV base square. So KV base square into by KVA base into 1000. Now this 1000 if we put here, so it will be KV base square but by KVA by 1000. That KVA base 1000 means it is MVA base, so it will be converted to MVA base. So we can say Z base is equal to KV base square by MVA base. So it is one derived formula, KV base square, it is equals to ZKV MVA base, and from this Z base is equal to Z KV base square by Z MVA base. Now per unit, any per unit value equals to, it is the ratio actual value by base value. Of the same quantity. That means if it is current per unit power, so per unit power in KVA by divided by base KVA. If it is current in actual current in amps by base current, and that will give the per unit value of current. Similarly, per unit value of impedance actual Z by base Z. Base Z means from this we will derive. So from these two formula we can derive, from these two formula we can derive that per unit value of any three-phase quantity, per unit value of any three-phase quantity Z of three-phase system, per unit Z is equal to per unit of three-phase is equals to per unit Z of single-phase system. So it's one important conclusion. So let it derive. So these two are known. So first let's write it in small note. Z is equal to Z base equals to KB base square by MVA base, one quantity, and per unit is equal to actual by base. We'll prove that Z base three-phase system equals to Z base single-phase system. We'll prove it. Now, let the system is three-phase star-connected system. Three-phase star-connected system. Then we can say line voltage VL is equal to line voltage, and we can say that is V three-phase system is equals to √3 times of phase voltage. That means it is equals to √3 times of V single phase system, because in single phase system we consider phase voltage, and three phase system we consider line voltage. So it is one conclusion. So, and also power in three phase system is equals to 3 into power of single phase system. You know that three phase power is nothing but multiplication of 3 single phase power. So by these two we will see the Z three phase is equals to Z single phase system. Okay, let's see. So I can erase it. I think okay. Now Z base single phase system is equals to Z actual value, Z base single phase system, Z base single phase system. Before that we have to do Z per unit of single phase system is equals to Z actual by Z base in single phase system. Z base in single phase system. Per unit, we know that per unit equals to actual by this. Now here we have Z per unit value based on three phase. I have to write it. Z, please rectify it. Per unit value of single base on single phase. That means per unit value is same. So per unit of Z of single phase system, Z actual by Z base in single phase. So now Z per unit value of three phase based on three phase is equals to Z actual by Z base on three phase. Now Z base on three phase. Z base on three phase, that means this, if it is single phase, so this will be the single phase voltage and this will be the single phase power. If it is three phase, then this will be the three phase voltage and this will be the three phase power. So Z base three phase. So it is equals to Z phase, Z actual by Z base in three phase. Z base in three phase. Okay, Z base in three phase. Z base in three phase. That means Z base in single phase system. Okay, let's rewrite. Z actual, Z base. So convert it. KV square. KV, that means KV base three phase square by MVA base three phase system. Now this MVA base three phase system in KV base three phase. That means we can convert it KV base three phase system. That means VL. So instead of that KV base three phase system, we can put √3 into KV base single phase system square. MVA base three phase system. Now it will come in upside. So MVA base three phase system MVA base three phase system basically MVA Z actual by Z three phase. Z three phase means KV square by MVA. MVA three phase system. MVA three phase system means, once again, it is, we can convert it 3 into MVA of single phase system. We can convert it. And it can be if it is come outside, then it will be 3 into KV base, and if it is converted, then this 3 into like this, and 3 will be cut, and then KV base square by MVA base single phase. So it will be like this. If it is like this, so we can KV base square by MVA base, Z base. It is single phase. That means it is Z base. It is Z base of single phase. So Overall, you can say this is Z base of single phase system. Z actual by Z base single phase system. It is the per unit of single phase system. So instead of these, we can say this is Z actual by Z base single phase system. So we can say Z per unit three phase system equals to Z per unit in single phase system. Three phase system Z per unit and single phase system Z per unit, both are equal. From this important conclusion, we can conclude that in three phase symmetrical system, per unit method, everything will calculate in single phase system, because Z three phase system is equals to Z per unit single phase system. So per unit method, all calculation is in single phase system. Okay. Now, so from these two important things, Z base, Z per unit three phase equals to Z per unit single phase system. These two are important conclusion. Now, if we suppose Z actual value, Z actual is in X ohm, Z actual in of one inductor, value of one inductance is X ohm, and it is based on its KV1 base voltage and KVA1 in base power. With this base, its per unit value, suppose its per unit value is Z per unit in with this system, Z per unit 1, it's Z1 per unit. Suppose this is Z1 per unit value. With this, what is that? Again, actual value, Z actual value. From this, Z actual value by kV square by kVA by 1000, because that is MVA formula. kV base square, Z base, and from Z base to, first by using this we will find out Z base, because Z base, Z1 base equals to, what is that? KV1 square by MVA1 from Z base. So Z per unit, Z1 per unit value will be how much? Z actual, and that is X by Z1 base. Z1 base. Now assume this inductor is same. That means it is again in X ohm. Now we have to find out its per unit value in another voltage, KV2 voltage and KVA2 voltage. Again, in that Z1, Z2 base how much? KV2 square by MVA2. It is like that. Now, Z2 per unit equals to actual value upon Z value. actual value once again x, and it is z2 base. Z2 base. That means per unit value of actual this x reactance with this base is Z1 per unit, and same x with another base kVA and base kV, its per unit value will same. Now we will see what is the relation between these two. Now assume Z1 equals to Z1 per unit equals to Z per unit old, and Z2 per unit is equal to Z per unit new. We can consider it. This is old one and this is new one. Now we will see what is the relation between these two. And once again, here it is base voltage, and from this we derived it. So let's start. Now Z per unit old, what is that? Z per unit old means this one. Okay, and this per unit Z2 per unit means Z2 base. Okay, so let's start like this. Now suppose Z per unit new by Z per unit old. What will be that? Z per unit new. That means this two. So x by Z2 base. Z2 base. Z2 base by Z per unit old. Z per unit old means, or we can say, suppose x by Z2 per unit Z2 base, and old per unit x by Z1 base. We can write it. So it is equals to x by Z2 base into Z1 base by x xx and is, so it is equals to Z per unit new by Z per unit old is equals to Z1 base by Z2 base. Now Z1 base. Z1 base means Z base. Z base formula. Z base formula. It is equals to kV base square by MVA base. So convert it kV base. So kV base, it is kV 1. 1 means old. So kV old square by MVA old. MVA old. So let's write it here. Z1, that means KV1, 1 means old, square by MVA old into Z2. Z2 means KV new square by MVA new. from this, you can say Z per unit new is equals to Z per unit old multiplied by kV old by kV new its square multiplied by MVA new by MVA old. It is another important conclusion. What is that? If we change base, if we want to change base from one per unit system to another per unit system, then Z per unit in new system will be Z per unit old system into kV previous old voltage by new kV, that is new selection voltage kV new and into kVA new and MVA. What is that? kV old, that means in previous case that means at the time of calculation of Z per unit, in previous case, that is an old system, whatever the base voltage is selected, that is kV old. In previous system, what was the power kVA was selected, that was, if kVA is selected, that will be converted in MVA, so that is MVA. So these two are related, and in per unit system, in new system, obviously we have to select one base voltage, and that base voltage is new kV new, and one new power kVA, that is kVA new to converted in MVA new. So it's clear. So Z per unit is equals to Z per unit old by kV old by kV new square multiplied by MVA new and MVA old square. Okay. So this is one important conclusion. So this is derived. So what is Z per unit new equals to Z per unit old into voltage, it is kV old by kV new square into MVA new divided by MVA old. So all this from this we have concluded. And now one more important conclusion is that selection of base kV. Suppose that it is one alternator, it's 5000 kVA, 3-phase, 11 kV, 5% reactance. It is connected with a step-up transformer. Its one side is 11 kV, in other side it is 132 kV. It's suppose 3000 kVA, its power 3000 kVA, and it's obviously 3-phase system and 3000 kVA and 11 kV, and it is suppose 15 ohm in LT side. What is that? It's reactance. That means XL. Actually, in case of transformer reactance, we consider only leakage reactance. In case of alternator. In previous class we have told you the alternator three reactants. One is subtransient reactant, transient reactants, and steady state reactants. But in case of short circuit study, we will consider only subtransient reactants. But here we will consider the leakage reactance. So it is XL 15 ohm in this side, and here it is. Once again, this is transmission line. Here it is again step down transformer 132 kV. So transmission line, if its reactance is 10 percentage reactance 10%, and if it is 11 kV, and after that there is load is there may be several load value is not given here. Now one important thing, here transmission line kVA, assume it is once again 4000 kVA maximum power. It can be chosen like that. Here transformer, assume it is only 2500 kVA, and its percentage reactance maybe, if percentage reactance is 10%. You can now see from this power system network, it is one single line power system network. From this we have to select one voltage as base voltage and one power as base power. Now we assume its base power. So kVA base equals to 5000 kV. 5000 kV, and it is equals to, in MVA it is 5 MVA. And base voltage, what is that? kV base, we assume if it is 11 kV. It is important. It is important because here everything, and it's everything, here it is 5000 kVA, 11 kV, and 55% is reactance. Here the base kV is how much? Here. So base kV and and its own kV is same. Its base kV. So we can say base kV means it is 1 per unit power. So it is, we can say this is 1 per unit power, and we can say 11 kV is 1 per unit voltage. So its voltage, instead of 11 kV, we can say it is 1 per unit. Why per unit? Because per unit system means we know that per unit value, V per unit equals to V actual by V base. Here V actual is 11 kV and V base is also 11 kV. So it is kV converted, it's 1. That means it is 1 per unit. Similarly, its power is 1 per unit. Once again, P actual, power actual by power base. Power actual is 5000 and power base, it is also 5000. So it will be 1. Okay. Now, what will be its Z per unit Z? Per unit Z we have to derive. Per unit Z we have to derive from this. And one more important thing. Here the base kV is 11 kV. Here the base kV is 11 kV. But in the transmission circuit, the base kV is not 11 kV. It is 132 kV. Then you can say, sir, in the same circuit, how the base kV can be different? Yes, it can be different due to this transformer action. Here, the transformer step up the voltage, so base kV also step up. So here the base kV, here it is base, it is base kV. If it is 1 per unit voltage, here it is 1 per unit voltage, here the voltage will be 12 per unit, 12 per unit. Here the voltage will be 12 per unit. Voltage is 12 per unit, but here the base kV is this. Base kV is this. Okay, clear? So it is not a 12 per unit voltage here and 12 per unit voltage here, like that. At the time of calculation of impedance, we have to take this one as a base kV. Here, when the load side will calculate, 11 kV 1 second will be calculated as a base kV. If it is, instead of this, if it is 132 to 220 kV, suppose that 220 kV, and after that, so here it is 132 kV, here it will be 220 kV. So in this side, up to this, it will be selection of base kV is 132 kV, but here in this side, this transmission line, base kV will be 220 kV. It assume it is once again 220 by 132. So this side, that means every time this is, in this case, here it is 220 by 132. So this side, this transmission line selection of base kV will be 220 kV. Here to here, the selection of, for this transmission line, selection of base kV will be 132 kV. From here to here, it is selection of base kV will be 11 kV. Here it is 11 kV. Okay. Now, digit. Z base is known, so Z per unit is equals to, Z per unit is Z actual by Z base. That means Z actual into Z base. Z base means kV base square and MVA base. Now Z actual, Z per unit, Z per unit, Z actual, that is, in case of Z actual, that is, it is a constant value. And MVA base, that means we can say Z per unit system, in case of Z per unit system, it is Z directly proportional with MVA base and it is inversely proportional with base kV square. We can conclude it? No. From this, it is another important, Z per unit, Z actual by MVA base square by Z kV square. Now, if Z is expressed in percentage reactance, that is 5%. Reactance is 5%. Then Z per unit will be Z actual, that means 5 by 100. assume its K kVA base is equal to 11 K. Consider the case of generator. Consider the case of generator. In previous case, it was 11 kV and 5000 kVA. That means it is equal to 5 MVA. 5 MVA. Consider the in case of previous one. So 5000 kVA. So it will be 5 by 100 in kV square. MVA base. MVA base means 5 MVA by kV square. kV square means 11 square. And its value will come with this. We will find out the Z per unit. So it is another Z actual MVA base by kV square. And if it is, instead of this, if it is 15 ohm, if value is 15 ohm, no problem. It will come as a 15 ohm. It will be come as a Z per unit. It will be 15. Now it is MVA base but kV square. We'll get the per unit value. Okay. So Z per unit is equals to important formula MVA base by kV square. Okay. So I think from this per unit quantity is clear to you. And once again, per unit system it can be summarized in like this. For per unit system, we have to select one as a base kVA base. We have to select it, and we have to select the base power. It is, we can say this is a base power. And if it is kV base, we can say this is a base voltage. And from this, we have to derive base current. Base, we have to derive it, base current. And from this, we have to derive base impedance. So these two are derived unit and these two are select unit. And from that, we will, if the transformer is there, if 11 kV, it is 132 kV, then in this side, the base kV will be 132 kV. So like this, we will convert in the circuit, overall the circuit, base, if there is transformer, base kVA, base power will remain same throughout the circuit. But due to transformer action, the base kV will differ from position to position. Base kV will differ from position to position due to transformer action. If it is 132 kV, that means here the base kV is 11. In this side, base kV will be 132. If you want to calculate, if it is 10% reactance here, though it is assumed and it is, suppose this side 2000 kVA is the power. So its own power is how much? So first you have to select it. First, if it is 5000, in case of generator, 5000 was base kVA. So here the conversion, only the voltage will be different. If here alternator kVA, 5000 kVA select as a base kVA, but here it is not 5000, assume it is 3000. If it is, if voltage is here 132, but base kV was selected as a 11 kV. Here the voltage is different, 132 kV. Base kVA was 5000 kVA, but here the base kV is 3000. In that case, In that case, we have to use the this formula. That means Z per unit in new system. Z per unit in new system is equal to Z per unit in actually first you can convert it first Z per unit Z per unit Z per unit its own based on own. What is that? Z per unit actual value 10 by 100 Z actual divided by Z actual Z base in own value. So Z actual divided by its kV base Z per unit, take the Z per unit, Z per unit, Z actual, use the formula Z kV square by MVA base. Now here the base kV, right, it is 132. So instead of this, it will be 132. MVA base, it is MVA, it is 3000. So Z per unit will be converted. Z per unit will be determined. And we can say this is old. And next time, Z per unit, new Z per unit, Z per unit in new is equals to Z per unit old into Z per unit old. Z per unit old by Z V per unit voltage V old by per unit kV voltage old by kV new. That means previous voltage was 111, it is 132. Its whole square into MVA base new. MVA base new 3000 divided by MVA base old 5000. From these we will get the Z per unit. So here the Z per unit will be converted. Clear? So that means if the voltage here 11 kV, it is possible for this case voltage is another thing. Okay? Because due to transformer action. Now we will take few more examples for problem and we will try to solve it.